we can say
not just for school. Alright, section 1.8. What were we doing with functions? There were 5 things to learn. This is technically 6. The first 4 were all on one page at the very beginning of your notes.
Some difference, product, and quotient.
Okay, so we were adding things together, we were subtracting, we were multiplying, we were dividing. What was weird? The actual operations of adding, subtracting, multiplying, dividing? Or the notation?
The notation.
Exactly. So we had to talk about new notation in section 1.8 because it was a little weird, which is why I even highlighted these formulas and said, hey, when you see this, what do you have to remember that the parentheses don't mean? Good. The parentheses don't mean multiply. They mean of, like function notation. So this isn't f times x. It's take f of x and add in the g of x. And maybe this didn't really hit home until you got to homework. But I told you, you only go further. After putting the plus sign in between the two functions, you only go further if you can combine like terms. And if there weren't any like terms, you should have stopped, boxed it, and been done. A few of you guys, when we check homework, you're going to realize you went way too far because you just didn't believe that you should have stopped when you could have stopped. So some of you made it wrong by keeping going when it wasn't legal. You only keep going if you can combine. Only keep going if you can combine. Only keep going if, well, you can do something legal on product and quotient. Okay, those were the first 4 things. Practice that a little bit, and then what came next? Oops, practice that a lot. What came next? Okay, once again, what do we have to be careful of remembering? What does this parenthesis not mean? Does not mean multiplication. Over here, same thing. These parentheses do not mean multiplication. The little o, some people call it fog because it looks like a little baby o. Either way, it's f of g of x, which is what I have down here, f of g of x, which means g of x is the input for f. G of x needs to go into f's argument. So we did a couple examples, I think, didn't we? Oops. We did a couple examples on Friday. One of them, we said, hey, let's just do plain old f of g of x. So I showed you g has to go into f. So we set up f's formula, which was input plus 2, somebody plus 2, and who was the somebody? Who's g? So that's why we went ahead and put it in. What I did not get to write on Friday, and some of you this might be helpful, if you got stuck on homework when you came to compositions, another way of looking at it is maybe before this step, thinking of it as somebody plus 2, and who got or who needed to get put into the input of f. So some of you might have been or might be helped a little bit if you were to write g of x plus 2 and then substitute who g of x is. For some of you that notation might help, so you might want to write that in the example. But then the name of the game was just, we'll get rid of those parentheses, combine like terms, and you're done. And we just talked about how you could rearrange the answer, what it would look like to keep the negative with the x squared as later. What was different about letter C? Letter A, we ended with a formula. Letter C, what did we end with? Yeah, an actual number. How come? Because F is getting plugged into G, but who's getting plugged into F? There's no X, right? The X has been substituted for. So if you guys notice down below, it might have once again helped some of you guys if, looking at the example, you saw that G was 4 minus somebody squared. And who needed to go into G? F of negative 2. And who was F? Wasn't it somebody plus 2? And who needed to be the somebody plus 2? Negative 2 got plugged in. So negative 2 got plugged in to the x plus 2. That all got plugged in to the g, which is 4 minus somebody squared. And all we had to do then was negative 2 plus 2 was 0. 0 squared is 0. 4 minus 0 is 4. Okay, so those were compositions. I just wanted to quickly remind you where we were in section 1.8, because all of that leads up to decompositions. Decomposing bodies. What's going on? The body is decomposing. What is it doing? What's it doing? Breaking down. Sure, I like that. It's breaking down, right? The body's breaking down into its most elemental pieces, aka from ashes to ashes, right? So, well, it's probably already dead by the time. Either way. It is breaking down. So, here's the idea. Composition. It's all been put together. What do we have to do? Break it apart. So, this is, look. This is the end result of an H going inside of, or into who? Who'd the H go into?
G.
A G, and then the G of H had to go into F. Okay? If you have colors, here we go. Let's color code. We're trying to look for who's on the inside. In this one, they told us there are 3. So looking for who's in the very inside, who's in the middle, who's on the outside. Now, I usually use this illustration for calculus, but you can do it in here also. There's a property in calculus that this is helpful for, but actually, you guys know what this is illustrative? How do you say that? Illustrative. Illustrative test? Illustrative. Illustrative. Well, illustrative. Why doesn't that sound like in my head?
Representative.
That sounds a lot better. Okay. Not baby chicks.
Russian nesting.
The Matryoshka.
It's a Russian nesting doll, otherwise known as a
Matryoshka doll.
Matryoshka. Okay. Yeah. Okay, so I wish I had real ones, but I don't. Everyone ever goes to Russia, you should get me some. So, ready? Okay, there's an outer function, there's a middle function, and there's an inside function. Little baby ones are down here because I didn't need them. We only need 3, okay? So we have an inner, we have a middle, and then we have an outer, true?
Yes.
Okay, so we're trying to break down who's the innermost. Now, it's kind of hard. With this one, it's easy. It's like, oh, it's the smallest one, right? No big deal. This one's the cuter one. Maybe I should. Okay. Who's the innermost? Anyway, so, if you ever played with Matryoshka doll, it's so fun to see how small they get. But anyway, party poopers, here we go. How do we tell when we're looking at a function who the innermost is? Yeah, maybe. Maybe it's the one that's in the parentheses. Maybe it's the one that's under something being subtracted from and inside the parentheses. Does anybody know who H? No, there are, technically, according to the back of the book, if you're checking if I give you any odds, there are multiple variations. I would say there is a better way of looking at it. There is a best way of looking at it. Can anyone tell who the innermost function is? The one that is most within? I agree. Doesn't x plus 1 look like the most stuff is happening to it? It's being squared, and it has a -2, and it has a square root. Wait, square root -2 and a square root. Kind of sounds like our F and G and H, right? So, we could say h of x is equal to x plus 1. And I agree that is the best. Just a few of you might have done something like x plus 1 squared. It technically would be okay for you to say that. But from my perspective, needing to use these Matryoshka dolls and the idea of the innermost in calculus, x plus 1 is the best innermost. Okay, just like the word Matryoshka? Yes. It's a great one. Come back. It's all as good as like Porsche. Anyway, coming back. Just kidding. That is the best innermost. So what would be the outer, not the outside, but the one that is outside of x plus 1? Okay, so peel off the layer. We have green next. Sorry, I apologize. G of x. I like the squared, but the problem is, I think I need the -2. Can anybody tell me why? Why do I need not just the squared, but the -2?
Because it's part of that level.
Yeah, it's the entire middle level. Because what am I saving for the last? Now, once again, just a few of you are like, well, I can make it squared, and then the next one is square root of x -2. True. But once again, with my experience. Just, I'm saying this is the best one. Not the only one, but the best one. So g of x, now here's where it gets a little crazy. It is somebody squared minus 2, but h gets put into g. So once we say h is x plus 1, we need to ignore that, cover that, and just say, oh, hey, make that an input. And what variable do we always use for an input? X. I know it's weird. But once we establish that x plus 1, h is going to come into this spot. To mark the spot, x marks the spot. To mark the input spot, I just put an x. We'll check it at the end to make sure it makes sense. But g is somebody squared minus 2. And at the most basic level, we always use x to mark the somebody. So then what's f going to be? Square root of somebody. The most basic somebody we can use, which is square root of x. Now, can't you always double check that you have it right by actually taking the composition? I'm going to go ahead and box it. I'm going to go ahead and tell you guys you are right. Let's make sure that you understand why you're right. Just a few of you are like, well, I can write that down, but what does it mean? Okay, so how does this work? To do f of g of h, there's a lot of ofs, right? Of x, there was another one. Uh-oh, I can't do it. One more. There we go. Now it's good. Okay. Who's the outermost function? F. So I'm going to go ahead and I'm going to write a square root. Right? Square root of who? Who needs to get plugged into f? G. Who's g? This guy. I'm not filling in any of my x's because in the x spot goes the inner. So g went into the x, so that goes in. But I didn't write that x because who's going into g? H. And h is somebody plus 1. But the nice thing is, if h is of x, I'm allowed to put the x for him. Question, did it work? No. It did? Once again, was that the absolute only way that you could write it? No, there are multiple ways, but I would say that's the best way. Because we peeled back as much as we could. The x plus 1 was the most basic elemental inside piece. He was the innermost. Then we said, well, what's going on to the x plus 1? Well, he was being squared minus 2. That was the next, like Rainey said, level. So we took that next level, and then what was the outermost? What was the outer shell? What was the outer shell? The square root of x. You guys just keep on saying that. That's hilarious. All right. So decomposing is taking a composition and breaking it down into its inner pieces. Does that make sense? We're peeling off the layers. Onions have layers. Anyway, so. Oh, here's onions? Anyway. Ready? Color pen. Let's check what you were able to do. A few of you need to finish up the decomposition ones tonight, and that's okay. Let's check what you were able to do. Because there was a lot that you were able to attempt. There's one nice one that's colored. Andrew. Does anybody know Andrew? Can you say his last name? Jacques. He graduated with like Chris Bennett. He had fun. He colored it. Alright, kiddos. Oh, he never got colored. Okay. Number 2 is the composition. You guys definitely, though, want to get all your points for homework. So did you just write one word? Number 10, you might have gone too far. You might have gone too far. Check it out. Did you have to go any further? Were there any like terms? No. Some of you went too far. I tried to warn you. You only had to keep going if there were like terms, and there are not. One of them has a square root, one of them has a denominator. No need to keep going. Just add the plus, add the minus. This one they kind of kept going. They just made it a nice fraction. So they made it over 1, and then they put the numerator together, denominator together. This one kind of the same thing, except when you divide by a fraction, what do you multiply by?
The reciprocal.
Uh-huh. Which is why they went ahead. Had that guy, and then they multiplied by. But once again, they didn't go bringing anything inside of anything else. The square root separates, it's a barrier. We're stuck. You can't come within unless there is a, well, I'll just stop for right now. In these ones, you could not have come inside the square root. At the very, very bottom, it got a little tricky because as soon as you have a denominator, a new denominator, you have to be careful. It was asking about the domain of the composition. So there were actually a couple different things that we had to be careful of. And this one, the domain, it was looking at the square root because that was our problem. There were technically two different problems. One problem was the x squared plus 1, but if anybody actually went checking that domain problem, with the denominator for g of x, question, can x squared ever equal a negative 1? Yes or no? How come? What happens when you square root both sides?
No, wait, no.
When you square root both sides? Yeah, it's imaginary, right? Oh, so, okay, that's not even going to happen. I can never have a 0 in the denominator because it's just an imaginary number. Okay, so forget that. We're looking for real domain issues. So what was going on with the square root? Why did they have to check him? What's not allowed underneath the square root?
Negative.
Yeah, we just talked about that, right? So, going back to our domain problems, you have to take what's underneath, set it greater than or equal to 0. We haven't really reviewed inequalities yet. We are going to have a whole section where we actually review what to do. Some of you right now would just say, hey, add the 4, square root both sides. The dilemma is, when you square root, you actually have to plus or minus square root in order to cancel that out. And the dilemma is the positive square root, which is 2. The principal or the positive square root, which is 2, is going to keep the inequality the way it is. But as soon as we do the negative square root, and maybe a few of you can follow this, the negative square root, the inequality has to flip. Positive square root, the inequality stays the same. The negative square root, the inequality flips. Technically it's review, but I know it's been a while. And we together as a class haven't been able to reteach / re-go over this idea. So I wanted to quickly just show you why. First of all, there's 2 different pieces to the answer. And second of all, why the inequality flipped. Just think of it as multiplying by a negative when you do the plus or minus, so the inequality flipped to that negative. Alright, I know that's kind of weird. Some of you just went too far because you thought you had to keep going, but you didn't. Make sure that if you did go too far, that you cross out what you weren't supposed to do. Oh, this is going to take forever. We'll just keep going. You cross out what you weren't supposed to do, and you box where you should have stopped, okay? Number 18, let me give you a second. Number 18, let me give you a second. I need you to check the formula first after you check the final answer. Check the final answer, get the right one down if you didn't have it, then come back, and I would write this as your first step. It's an easy one to confuse. You weren't multiplying by t minus 2, you were plugging in t minus 2. F of t minus 2 plus g of t minus 2. Number 32, you guys can kind of start seeing down below. This is where the composition started. We're in the 30s. Remember, check the answers first. And if you don't have the right answer, go ahead and get the right answer down. Then if you have time, go backwards. Now is not the time to frantically write the whole problem. A is 20 minus 3x, B is negative 3x. C, they should have undone each other. You guys haven't learned that yet. So same thing. In a sense, everything should have canceled out except for x. I'll put it that way. Number 42. If you guys notice in the problem, I think it said something about consider the domain or find the domain of the composition. If you guys notice, what they did first of all was looked at them separately and said, hey, what's this guy's domain? Everything but x can't equal. It says except. Another way of putting it is the way I would, which x does not equal plus or minus 1 for the domain. That works too. This guy had no problem, so he's just all real numbers. Then they went ahead and did the math of plugging g into f, simplifying. Ooh, careful, what did they not kill? What did they not kill? Which one kills a puppy if you just quickly square it and don't foil? Oh, yeah, I just said it is a puppy. They FOILed it out, x plus 1 times x plus 1, they simplified. Got the final answer. But then they looked at their composition and they said, ooh, you know what, from this, x squared plus 2x cannot equal 0. What did I tell you guys? Whenever you're setting equal to 0 or not equal to 0, what do you have to remember to do? What math? Josh, what math do we have to remember to do whenever we have something equal to or not equal to 0? Who can help them? What math do you have to remember? Yeah, kind of. What part of algebra? Factoring, I think so. You gotta factor. You gotta pull out that x and have an x plus 2. X cannot equal 0. X cannot equal negative 2. True? There's baby Josh. Okay. There are two of you, so just whichever one is looking at. So x does not equal 0 and x does not equal negative 2. Yeah? Okay. Last but not least, plug into g. Plugging f into g at the end of the day is kind of like the beginning one. X cannot equal plus or minus. Alright, we get rid of all this stuff. You guys can already see if you have not already started looking at 44 and at 52. 52 is where the composition happened, or the decomposition, right? Not going on. 44, we did an example like in class, A and B. We did something kind of like A. 52, here's one way of breaking it down, but long story short, some of you didn't get to that D. Hey, that was the last even. That wasn't too bad. So the decomposition was literally the last problem. Was it 49 also? Yeah. Okay. So 49 and 52, a few of you guys might need to go back to the decomposition ones and try 49 and 52 again. I'm going to go ahead and let you guys check 52 first thing tomorrow. Today is chapel day, so I'm going to check, or have you guys check the decomposition ones first thing tomorrow, and I'll take any questions you have remaining on the odds. So if you did miss anything, look over it tonight. Come tomorrow with questions that we need to look over, but first of all, try to figure it out on your own. Okay? Here we go, section 1.9. Looking at the backboard, we are only starting this today. Homework is not due until Wednesday. But. Let me show you guys your calendar. It is fully up to date until the next test, which is Friday. It was technically supposed to be Thursday. I did move it to be Friday so that we had a little more time. So we're just starting 1.9 today. Finishing 1.9 tomorrow and starting 1.10. Finishing 1.10 on Wednesday so that we can have a full review day. Oh, finishing? I don't think we need to finish it anymore. Sorry. We'll be able to have this full review day for the Chapter 1 test review. And then we'll have the test on Friday. But kiddos, what are you trying to get in by Wednesday? Test corrections. If you guys notice, the end of the first grading period is Friday. I did go ahead and get this weekend your graphing calculator quiz bonus corrections into your grade. So your graphing calculator quizzes, you guys did corrections on those to try to get some points back. Whatever points you were able to get, I went ahead and added them in. I have the quizzes if you want to come look at them. Some of you didn't correct it as closely or carefully as you should have. So you can go check out your RenWeb grade. Long story short, your test grades are in there as is right now, and some of you really need to get some points back. How do you get points back on Chapter 1A test? Corrections. But is it enough just to kind of like BS your way through and make up some stuff? No, I'm checking to see if you get it right. I'm checking to see if you understand it, or you can show me how to do it now. So if you just randomly write stuff down, is that going to get you points back? Probably not. But if you know how to do it correctly and write that down, well, that gets you points back. Yes. So corrections are due on Wednesday. What if you don't know how to do it? You missed it on the test. You're going to miss it again maybe on your own. Come ask me. Ask other Precalc kids. Look in your notes. Look in your book. Ask some honors Precalc kids or calculus kids to help you out. Remember, we talked about this. I'm in here during lunch. Today, I have a meeting, so that's not going to be good. But tomorrow and Wednesday, I'm in here during lunch. You can come ask me then. I'm in here 7. Ooh, today's a bad week for 7th period. 7th period is a bad one, but if you need me to be in here 7th period, not today, but any other day this week, I can be, but I'm planning on going and observing a math department chair, yada, yada, yada. I have to go look at other teachers. But if you're like, I need you and I can only do 7th period, talk to me today so I can plan out when to be in the 7th period. Otherwise, I'm in here every day after school. Okay? Get these corrections figured out because, one quick note, last logistical thing. The test on Friday. I have decided to put a few questions from the Chapter 1A material on the test on Friday. Now you might be like, oh, that's going to be awful. Except, weren't there some easy things on the Chapter 1A test? Like, if x is -2 and y is positive, what quadrant? Wasn't hard as long as you remembered your quadrants. Or something like, is the following point a solution to this equation? What were some other things from Chapter 1A? The domain, we've been practicing that a lot, so I'd love to maybe put a domain problem or two in there. Anyway, I'm going to go ahead and put some Chapter 1A material, just a bit, on the test on Friday, because aren't you guys reviewing that anyway with the corrections? Okay, so you're going to have that in your brain anyway, so I'm going to go ahead and put a few things. Don't worry, in the review on Thursday, I'll go over the specific topics for you to make sure that you have done. But there's also a test review in your homework or on your homework sheets that we're going to be working on problems together on Thursday. I'm going to be here, no jury duty, so that's a blessing as well. Go ahead, Chris.
Are we going to have any bonuses on this test?
Probably. I usually try to throw in at least one. All right, cool kids. So we're doing the corrections not only for points back, but also to prepare for the test on Friday. That's going to have not only the stuff from 1.6 to 1.10, but also some from 1.1 to 1.5, because to be honest, the stuff at the beginning of the chapter is usually a little bit easier. So if you can just figure out your mistakes, maybe those can be some of the easier problems on Friday. If you finish your corrections early, as you guys are starting your notes, if you finish your corrections early, let me show you where you can turn them in. Here in the back of the room, there are trays for each of the periods. And there is a manila folder. Some of them are missing right now because classes have already turned in corrections last week. There is a manila folder back here. If you finish your corrections early, the manila folder says correction period 2, that's you. You can come in any day after school, or if you have them done in class as you leave. For instance, I already have AJ's back here. You just throw them in the folder and they'll be nice and safe, and I'll hold on to them so that you don't lose them. Because if you lose your test, can you do corrections?
No.
So not only will you not get points back, but you will also get a 0 on the assignment and have no way to make it up. So when I give you a test, you hold on to it carefully. If you're afraid you'll lose it, as soon as you finish, turn it back in to the middle folder. Alright, kids, section 1.9. Any quick questions on any logistics that I was saying? What the test? Or corrections? Or when I'm available to help? Inverse functions. Have you guys ever seen the -1 before? As a power?
Yeah.
Yeah. Almost always when you've seen it in the past, almost always, last year, hopefully you saw it first, but almost always when you saw the -1 in the past, it usually meant reciprocal. So I'm going to show you the difference between where this -1 is. It's all about the placement. And where this -1 is. If I wanted the reciprocal of f of x. If you remember this is good. That means you remember negative exponents mean flip whatever you have. If it's not in a denominator, put it in a denominator. If it is in a denominator, flip it up. If there was a negative 1 on the outside of the whole function, then I would flip it. If there was a negative 1 on the outside of the entire function, they would have to put big old brackets and have the negative 1 be on the very, very, very outside. Then you would say, it's time to flip f of x and make it 1 over. It's time to take the reciprocal of f of x and put 1 over. But this is the only time I would take the reciprocal of a function, is if it's on negative 1 on the outside. What's the difference up here? It's on the inside. And since it is on the inside, it does not refer to a reciprocal. Instead, it refers to an inverse. So if you guys realize, in I think the last 3 sections, we've been really having to fight against notation. We've been having to really fight against notation. It started way back when, not way back when, but a few sections ago when I was asking you to do something like, hey, find f of 2. How did you have to fight against notation on this? What does this mean? What are you supposed to do to find this? I know I didn't give you f of x, but what are you supposed to do to figure this out? Plug in 2. Good. Plug in 2 for x. Question, why is there a fight against notation? If you're in Algebra 1, if you can go find an Algebra 1 kid right now and say, hey, what does this mean? Oh, they're going to be like, yay, I got it, it's times. Is that right? No, not in function notation. So we had to fight against notation on this one. What if, or what about when I went ahead and did something like this in last section? Just got a step harder. How do you do that? Plug in, yeah, this is crazy. Plug into 3 where?
No.
Uh-uh.
For
For x in, plug into 3 for x in who? Find the notation. Hold on, this is even confusing. Let's write it a different way. F of g of 3. Think of the Matryoshkas. Where is the 3 going into? The g. If you plug into 3 for the x into g, then what do we do? Then plug in g, and technically plug in g of 3 for the x in him. For those of you guys that work well with words, that's literally what that notation is meaning. But once again, didn't have to fight against that notation. This section, no different. If you know the negative 1, that's a good job. An algebra teacher, algebra 2 teacher taught you well. If you know this negative 1 usually means reciprocal, but is that what this means? And the answer is no. I need you guys to go ahead and attach to the idea of inverse the word undo. This entire section. The word inverse, I need you to think of, for your brain to attach an idea reciprocally, like 1 over, hopefully. For function notation, hopefully you're like, plug in. But for inverse, I need you to attach the idea of undo. And what do I mean? Let me start showing you. Let me start showing you. You guys actually had an inverse in last night's homework. I saw it, and I started to talk about it, and I said the word undo, and I'm like, oh, you guys haven't seen that yet. A composition, I should say when a composition of 2 functions, it could be the same function, it could be different functions, but when a composition of 2 functions ends up just equaling x, no adding, no subtracting, no multiplying, no dividing, no exponents. When a composition of 2 functions, maybe they're the same, maybe they're different, ends up just equaling x, those 2 functions are inverses of each other because the one is undoing the other. So we super poetic and say the one is the undoing of the other. But the one undoes the other. And as you guys are writing, just because we're not going to get past this page probably today, I'm going to throw a little example in here. We'll call f of x. Don't worry about my example. Worry about giving you information. Makes sense. Inverse basically answers the question, given a certain function, how would we undo him? How would we undo him? The way to check to see if you've undone him properly is to take the composition of both the functions and see if truly one really does undo all the operations, all the extra of the other. So what I've given you over here on the side is a function 3x minus 1. Question, what is occurring to the x? According to PEMDAS, what's occurring? First multiplying by 3. But what else is going on to x? First multiplying by 3 and then subtracting 1, right? So in order to undo the multiplication by 3 and the subtraction of 1, we would need to make an inverse function. We would call him g. We would need to make an inverse that adds 1 and divides by 3. Now, technically, if we had more time and we could do some exploration, I'd have you guys take the composition of this f and this g, but the problem is, the way I've written it, it wouldn't undo it completely until I put little parentheses. We could do this whole exploration, we could kind of figure out how the rules work, but there is this shortcut that you guys hopefully have seen before about how to solve for an inverse. You switch the x's and y's and you solve for. But we're going to have to say tomorrow. We're going to have to add tomorrow. We need to change the y. We're going to have to introduce and keep working with that notation. Kiddos, imaginary Valentine's group. See you guys later. Finish up 1.8 tonight. And my advice, work on those corrections, huh? See you guys later. Pick it up, bro. He's not feeling good, huh?